Okay, so what we're going to be talking about here is simple interest. So you've probably seen simple interest at some point, either last year or possibly in year 10. Okay, so I've just got there because it's simple interest. So let's go for the theory. So basically what the idea of simple interest is you start off with an amount using, I'm going to use this as an example here of just, showing it graphically. And so I start off with a certain amount down here, and that's what I call my principal. All right. And, it depends on your your rate of interest per period, number of times you pay it, stuff like that. But what you're basically doing is you're working out for each period of time, you're working out a certain amount. But that's always based on this initial value. So the increase you're getting each time is the same. So, which is why you get a nice straight line. So you've got a nice straight line there. Okay. Now, depending on what you've seen before, you might have seen something like this. Probably, if you saw it in year 10, you probably would have sort of seen something like that. I equals PRT, and you often go divide by 100, pretty much like it's written here. Now, this is within the newer study design, so it's been since 2016. They've changed some of the terminology, but it means the same. So I've got I is my simple interest earned, charged or earned, depending on whether you're trying to get money or you're borrowing money. V0 is your principal. So that's the money you've, say, put into the bank, or again, the money you've been loaned. Your R is your rate of interest per period. And N is the number of periods, so the years, months, days over which the agreement operates. So that'll be given. That's the sort of information that will be provided to you. Okay. Now, and that will, like I said, produce something that looks like that. So let's have a look. From that, if I know what my starting amount is, and I know how much interest I've earned from up here, I can work out my actual amount. And if you start thinking about when we talked about recurrence, this is starting to look like a recurrence, because that in this case, the interest is always going to be the same. The V0 is like my previous term. I think this is previous term. And this is next term. Okay. If you remember back to when I talked about recurrence. And so we can use this equation. That equation is important to realize. Now, just to sort of put this out there, you might have seen something that looks like this. These two are basically saying the same thing. A being the amount here, so that's represented by VN, the total amount of the loan or investment, plus equals P, so our V0, that's our principal, plus the amount of interest that you've added. Okay. Now, here's something to keep in mind. Sometimes we're not after I, we're after V0. So we're after the principal, or we're after the interest rate, or we're after the time of the loan. And so by using these equations as shown here, they've already been transposed for me, so I don't have to rearrange this equation up here, up the top. It's already done for me. So my suggestion is put this in summary, and these two in summary, in your summary book. Okay, because I think it's important you have that sort of there and handy. Okay. Now, as I sort of indicated before, we're sort of, what I was trying to sort of suggest by what I've got here is that we've got a recurrence relationship, and we're sort of showing this here. what we're saying is the simple interest can be represented by a first order linear recurrence relation, where Vn represents the value of the investment after n time periods, so Vn. VO is the initial or starting amount. It's near where you're using the zero there. And D is the amount of interest earned per period. Okay, so if your interest, and you can calculate that D is per period. So if it will say I've gone D equals V0 times R over 100. So say my interest is, let's pick an easy number. And we're doing it per, say it's per year, just because it makes our life a bit easier. So we're going to say per year. That is my time period that I'm talking about. So if I say that's 100 and that's 10%, so that's $100. Okay. All I'm doing here is going 100 times 10 divided by 100. And because I can cancel that out, I'd be left with $10. So after each time period, I earn another $10. After next time period, another $10, etc., etc. Okay, that's how that's working. But if you're asked to represent something in terms of a recurrence relationship, so if you're asked to show this as a it's probably more going to say recurrence relation, what you need to put is you go something like Vn plus 1 equals Vn plus, in my case before, plus 10, okay? And V0 in my example I just had before would be 100. So remember, you've got to put that V0, you've got to put that starting term. In this case, our starting term always refers to that sort of principal amount, okay? And I know I've stated this before, a recursion relation links one term in a series to the previous or next term in the same series. So V0 is my starting, then it would be V1, so after year 1, V2 after year 2, V3 after year 3. That's the previous and next term in the same series. We can use these equations to model financial situations as we're doing here, okay? We can set it in consecutive years with how it looks. So let's have a look at the first example here. So here's some worked examples. And just to note that this link here, that'll take you to how I was showing how you can calculate recurrence values using your CAS calculator. So that's another office mix that I've made. So you can click on that link and that'll take you. Remember, there's two ways that you can do it. Use the one that makes your life easier. All right, so we're going to set up a recurrence relation to find the values of the investment after n years. So n years being whatever time it's going to be. So what we need to find here is, we need to say what our recurrence relationship is going to look like. Is going to go Vn plus 1 equals Vn plus D, V0 equals some number, okay? Now, first we've got to find out D, because we don't know D, so we're going to do D first. And we actually know V0. So V0, remember, is V0 is up here. That's my the number of years. So that would be N, and this would be R. Okay. So I went a little bit blank because I'm used to using time for 5 years, and well, I didn't. My brain sort of went blank on me for a bit then. So, but my V0 here we know is 325. Okay. So let's work out D. So D equals, remember, V0 times R divided by 100. So that's going to be 325 times R. R is 3, because it's 3% per annum. Remember, per annum means, I should have highlighted this, per annum means per year, or annually means every year. Okay, divided by 100 here, and that'll give a value of 9.75. All right, that's per year. That's my interest per year. Interest per year. Okay, so how do I write that now? Let's change color. It's going to be Vn plus 1 equals Vn plus 9.75, comma, V0 equals 325. And that's if you're asked to set up a recurrence relation. Remember, this is a recurrence relation. That's what I'd be expecting. Okay. For B, I'm going to run out of room, so I'm going to put it over here. So for B, we do what I showed you in this clip up here. So basically, what you're doing, the idea of this is you want to find out the value of the investment at the end of the first 5 years. So you're going to have effectively something that looks like, and I'm actually going to put it in there, give us a moment. So you're going to have something that looks like this lovely little table here. So my N plus 1 is after my first year. So that means I start with 325, which is my V0. Remember, this here is V0. And I'm just going to be adding, remember, it's Vn. So in this case, I start off with V0 because that's my previous term, because I'm after V1. And I put 325 plus whatever the D was, in this case 9.75, and I repeat that. Now, as I said in the video I've done that you can link to, there's a couple ways you can do that on your calculator. Pick which one that suits you best, and follow that through. But as you go through, you'll find out that each year, after each year, this is how much you've got now. Okay. Let's have a look at number 2. Jan invested 210 with the Building Society in a fixed deposit account that paid 8% per annum, simple interest for 18 months. So how much did she receive after 18 months? Okay, so this involves 2 parts. The first part, let's write out the equation to why I say it's 2 parts. Because basically what you're after, let's go back to the theory for a sec. We're after this. So we want to say how much we've got. So it's going to be Vn equals V0 plus I. We know what V0 is, and that's V0. Sorry, it's getting a bit tight in here. So that is R. And now this is the interesting part. How do I represent that? Simply for 18 months, that's N. So N is 18 months, but I've got to convert that. I've got to convert that to years. So because I'm doing it in terms of per annum there, so I need to change that to 1.5 years. Okay. So I've got V0, so that's equal to 210. Easy. Now, here's the part I need to calculate. I need to calculate I. Okay, so I need to work out what I is here. So I'm going to go I equals V0 R N over 100. So that's 210 times 8 times 1.5 divided by 100, and that'll give you 25.2. So that's going to be 25.2, and that will equal to $35.20. Okay, so the total amount received at the end of the 18 months is $235.20. All right, so that's how you calculate that one. So in this case, my answer's here. So because I'm a bit short of room here, I've sort of moved things around a bit more so than I'd normally do. That's A. B, represent the account balance for each of the 18 months graphically. Aha, calculator. I've already worked out the time. My amount, remember, I'm going to have to start with V0. So I'm going to put V0 in there, is 210. I'm going to plus, it's going to be 25.2 times time, because that's the part, that's the variable, it's going to be changing each time. Okay, then I go enter. As you can see, I get a lovely data showing up like that. Then I just want to add data and stats, and I want to graph that. So that's going to be time. It's going to be amount. And bang, isn't that a lovely straight line? Okay, because that's how you would show that. So that's CCAS for this particular instance. If you're doing this in your questions, you can draw something that looks like that. So, third question. A bank offers 9% per annum simple interest on an investment. At the end of 4 years, the total interest earned was $215. So how much money was invested? All right, so what we've got here is R. What we've got here is N. And what we've got here is I. Okay? So we know what that value is. So basically what we can do is we can look at these equations back up here and go, oh, hang on, I'm after V0. All right? I'm after V0. And that means, let's go back. So I'm going to go, hang on, what was it? It was V0 equals, all right, let's go back. V0 equals 100 times I divided by R times N. R times N equals 100 times I. 100 times I was 215. Oops. Okay. R was 9 times my, remember it's per annum, so per year, that's my thing, times 4. So that will give an answer of 597.22. So the amount invested equals, or was, 597.22. So that's another example there. Okay, I'm going to try to get through this quick because it's going to take a bit of time. This has gone for a while as it is. When 720 was invested, so V0 for 36 months, that is N. But remember, we want yearly interest rate, so we're going to need to convert that to there. So that's 36 months, 12 months in each year, so that's 3 years. All right. So, and this is I. So, again, we've got R 100 over I, V0 times N. R equals 100 times I, V0 times N. So 100 times 205.20 divided by V0 was 720 times 3. And I put that into my calculator. Or you could do it like I showed in using the solve video, where you can just use the solve function. Okay. You don't always have to have transposed it, but it's up to you which one you prefer, and that'll give 9.5. So interest rate is 9.5% per annum. Last worked example, an amount of $255 was invested at 8.5% per annum. Again, let's actually change color. V0 R, and this is I. And so what I'm after is how long will it take? This is my N I'm after. I'm going to put a little question mark to say that's what I'm after. So let's write it. It's N equals, again, let's have a look at this. 100 over I, 100 times I, sorry, E over V0 times R. 100 times, what was my interest? 86.70 divided by V0. V0 in this case was 255. Oops, I just made that worse. Times R was 8.5. And that will give me a number pretty close to 4, or 4. Okay. We could calculate that if we wanted to, but I'm just going to say 4. And so, oops, I need to get that down. And so it's basically going to take, it will take 4 years. Okay. That's the key part. That's simple interest for you. Thank you.